Hi, we are Stefano Caiola and Matteo Mascia, application engineers for National Instruments Italy, and today we are going to walk you through the first milestone of Benjamin Franklin, a soft-core microcontroller architecture on LabVIEW FPGA. The reason why we decided to start this project is because we wanted to build a reprogrammable state machine on LabVIEW FPGA, capable of changing personality at runtime, without the need to build a new bit file. We wanted also give the user the ability to simulate offline the entire structure and a free toolchain that supports a high-level programming language to instruct the embedded device. For this purpose, we choose the Texas Instruments MSP430 16-bit microcontroller. We took advantage of a free programming toolchain already available for Eclipse IDE and an open-source clone of the core found on OpenCores, that is the heart of the FPGA design. This design can be built on every National Instruments product that comes with an FPGA inside, from the modular instruments market space with VST or Flex Trio to the embedded control market space with Compa Trio and Single Board Trio. The high-level architecture consists on a combined work of the Eclipse IDE, where a C file is built with the MSP430 toolchain to generate a .x programming file. The programmer is a LabVIEW VI that runs on the host, that formats the instructions contained in the X file and download them inside LabVIEW FPGA. The soft core is part of the LabVIEW FPGA design. It stores inside its program memory the instructions and runs them. Once the design is built for the appropriate target, the microcontroller architecture runs on real hardware and can be reprogrammed at runtime. The heart of the FPGA architecture is the core, integrated with an IP node that makes the entire MSP430 architecture available for simulation on the host. We choose the MSP430 because it's very popular and a lot of C libraries are available online. Thus, there is a potential for reusing code. The open core implementation available online is already FPGA proven and the project is alive. The input-output peripherals are LabVIEW based and software selectable thanks to disable structures to make the design even more flexible in choosing which interface needs to be included. Data and program instructions are stored in data memory and program memory, implemented with LabVIEW FPGA memory blocks. We choose for the design a 32 kilobytes program memory and a 4 kilobytes data memory for medium complexity application on the microcontroller. The DMA is in charge to receive programming data from the host and download the instruction into the MSP430 program memory. The peripherals currently available in Milestone 1 consist of 24 inputs divided into 3 blocks of 8 inputs each and 24 outputs divided into 3 blocks of 8 outputs each, 1 timer compare unit, 1 UART transceiver and an hardware floating point unit, able to handle 1 floating point operation every microsecond. Currently in development there are SPI and I2C transceivers and the DMA light bus with the capability of moving data between the microcontroller and other peripherals on the FPGA, eventually other microcontrollers at roughly 80 megabytes per second.
Now we are gonna show you an EcoPort example built for Benjamin Franklin. Starting from Eclipse IDE, the main.c file contains the C code of the example. The echo is done on this line when port 2 value is written on port 4. Pressing the hammer button, the compilation starts and the result is an X file that you can find in the Project Explorer and project directory. Let's move to LabVIEW. On the left side of the screen, the host VI is in charge to transfer X programming file to the FPGA microcontroller core, that you can see on the right side with all its FPGA controls and indicator. For this demo, a simulated Flex Trio target was used. Browse for the X file created from the Echo project in Eclipse and hit the programming button. Now you can verify from the FPGA side that a change on port 2 causes a change on port 4. Without stopping or recompiling the bit file, let's move to the C code to change the personality of the FPGA. We want to echo the value of port 2 on port 5 instead of port 4. Let's go back to Eclipse IDE, change the echo instruction and rebuild X file. Switch back to LabVIEW and hit the programming button again. There's no need to reselect the file because it was rebuilt in the same location. As you can see, now a change on port 2 causes a change on port 5. The compilation results shows that Benjamin Franklin can be built on different devices with different types of FPGAs with a maximum clock rate of 40 MHz. The architecture is built in 4 different configurations to show the flexibility that we can have thanks to disabled structures. Thanks to the small occupation of FPGA resources, it is also possible with Benjamin Franklin to build multi-core architecture. If you have questions or feedbacks, please follow Benjamin Franklin and iTalk page or directly contact by email one member of the group. We hope that you liked the video presentation and you are interested to try the design. Thank you for your time.